Hi everyone, I'm Dr. G. Swapna, Assistant Professor in the Department of Mathematics, VJEC Institute of Engineering and Technology. In the course Ordinary Differential Equations and Vector Calculus, we are going to be starting a simple topic, Euler Cauchy's homogeneous linear differential equation. Now, today first we discuss that how we remember or how we recognize Euler Cauchy's homogeneous linear differential equation, which is a special differential equation with a variable coefficients. In the variable coefficients, we have some special coefficients, particularly of the form x power n d power n y by dx power n plus a1 into x power n minus 1 into d power n minus 1 y by dx power n minus 1 and so on, plus an into y is equals to phi of x, where a1, a2, so on, an are the constants, which is called the Cauchy's homogeneous linear differential equation. Here if we observe, in each term, the degree of this term is n and also order of the term is also the same. So we call it as a homogeneous because of the same degree of the polynomial and the order of the derivative is also the same. And now we discuss how to solve this equation. Here we known that how to solve that linear differential equation with a constant coefficients. So our job is here to reduce this variable coefficients into the constant coefficients just by considering, let us consider x is equals to e power t, which means that t is equals to log x by logarithmic properties. Here we need to find the dy by dx. Here if we observe that we are changing that independent variable x into t. So we are finding y with respect to x. Directly we can't find it out. So we are using the total derivative, that is dy by dt into dt by dx. So here t means that log x, derivative of log x is 1 by x. So we are having dy by dt into 1 by x. If we multiplying on both sides with x, then we will get it as x dy by dx is equals to dy by dt. Here we have the standard notation dy by dx is equals to capital D, and dy by dt is a capital standard notation theta. So now we convert into the short form that x dy is equals to theta y, or we simply write it as xd is equals to theta. Now we will find out the second order derivative, d square y by dx square. Here if we consider, here this is a in this step we got that dy by dx is equals to 1 by x dy by dt. Using this, again we are differentiating on both sides with respect to x. So now d by dx of 1 by x into dy by dt. Now derivative of the two terms, product of two terms. Now we need to apply the derivative of uv. So d by dx of 1 by x into dy by dt plus 1 by x into d by dx of dy by dt. Here if we observe that here it is a dy by dt, that we can't differentiate directly with respect to x. So we need to apply total derivative concept. The derivative of 1 by x is minus 1 by x square, here dy by dt plus 1 by x into derivative of dy by dt with respect to t first, because we are applying the total derivative concept. Dy by dt into dt by dx. This is the total derivative concept. Now substitute that respective value, minus 1 by x square dy by dt plus 1 by x into d square y by dx square. d square y by dt square into dt by dx. So here what is the dt by dx value? T is the log x. So dt by dx value is replaced with 1 by x. Now we will simplify. We will get it as minus 1 by x square dy by dx plus 1 by x square into d square y by dt square. Now as we simplify, d square y by dx square is same as 1 by x square. Take 1 by x square as a common from these two terms. You will get it as minus dy by dx minus dy by dt plus d square y by dt square. Now multiplying x square on both sides, you will get it as d square y by dx square is equals to d square y by dt square minus dy by dt. Now we will write in the short form x square d square y is replaced with theta square y minus theta y, which is nothing but we can simply write it as theta into theta minus 1 into y. Now as we observe in the previous slide, we replace x dy is equals to theta y and x square d square y is replaced with theta into theta minus 1 theta into theta minus 1 into y, and similarly we replace x cube d cube y is equals to theta into theta minus 1 into theta minus 2 into y. If we continue like this, then and substitute x dy x square d square y plus so on x power n d power n y in the given equation. Here we have an equation is there. This is the short form of the equation. We substitute all these terms in this equation. Then this equation is reduced to LDE, that means that linear differential equation with constant coefficients. That is of the form f of d into y is equals to q of t, because we are substituting x as an e power t in the right hand side also. In the both LHS and RHS, we completely convert or completely substitute in terms of t, as x is equals to e power t and x dy is equals to theta y, and x square d square is replaced with theta into theta minus 1 into y, and so on. The total equation is reduced to LDE with constant coefficients. Then for finding the solutions of this equation, just we have some videos are already there. I will post those videos in the description box. Please look into that for more explanations and problems on that particular concept, that's LDE with constant coefficients. Now just we recap this. With a few minutes we will recap this. What is the solution of LDE? Linear differential equation with a constant coefficients. The solution can be written as y is equals to complementary function plus particular integral. Complementary function is depending on roots of auxiliary equation. And particular integral is, we will be find it out as 1 by f of d into q of x. That's a q of t. Now we need to evaluate this. It's depending on the given right hand side function, depending on the q of t, which we obtained from by the substitution of all those elements in the equation 1. Now we will discuss on the little bit briefing on complementary functions and particular integral. Here particular integral, already we discussed that auxiliary equation of the LDE is f of m is equals to 0. Just simply replace the d by m. Here and equate that f of m is equals to 0. And you are getting an algebraic expression of degree m. If a nth degree differential equation, then this is an algebraic expression of n same degree. Now if we consider this as a nth order differential equation. For the nth order, for nth order differential equation, we are getting nth degree polynomial, algebraic polynomial. Then we have n roots of that particular polynomial. Let us consider m1, m2 and so on, mn are real and distinct roots. Real and distinct roots. Then complementary function is c1 e power m1x plus c2 e power m2x and so on, cn e power mnx. If suppose m is equals to m1, m2, m3, m4 are the real and equal roots, and the remaining all n minus 4 roots are the real and distinct roots. In such a case, here we observe the first term c1 plus c2x plus c3x square plus c4x cube into e power mx. Here the 4 roots are equal, that's why we are taking here 4 arbitrary constants like this into e power mx plus, for the remaining distinct root, same as the logic of the previous one, c5 e power m5x plus c6 e power m6x and so on, cn e power mnx. And another case, m is a plus r minus ib are the complex roots. These are only the two complex roots. Those are the distinct. The remaining all are the distinct and real roots. In such a case, the complementary function is defined as e power ax into c1 cos bx plus c2 sin bx plus c3 e power m3x and so on. Because here also we are observing the same pattern of the first method, because the remaining m minus 2 are the distinct roots. Now for the last case, a is equals to a plus r minus ib, a plus r minus ib, or the repeated complex roots, and the remaining are the real and distinct roots. Here observe, a plus ib is repeated 2 times, a minus ib is also repeated 2 times. In such a case, we are writing the complementary function as like this: e power ax into c1 plus c2x into cos bx plus c3 plus c4x into sin bx. This is the formulas to evaluate the complementary function for the linear differential equation of constant coefficients. Now we will discuss about the formulas of particular integrals of linear differential equation with constant coefficients. If suppose, as we discussed, after converting the variable coefficients into constant coefficients, the equation is of the form f of d into y is equals to some q of x or some q of t, that's an independent variable. Then particular integral is of the form 1 by f of d into q of x. Here the q of x may be any function in the as a mathematical function, that may be exponential, sine or cosine or polynomial or combination of any of these three or any other functions also. Now we will discuss one after the other. If q of x is e power ax, if f of a is not equals to 0, just simply replace d by a in the denominator, e power 1 by f of a into e power ax. If f of a is 0, then we are using the formula x by f dash of a. Here the derivative of x by f dash of d into e power ax, and replace the d as a. This is applicable when f of a is equals to 0 and f dash of a is not equals to 0. Similarly, if suppose f dash of a is also 0, in such a case, and we are using x square by f double dash of a into e power ax. This is the method 1. In method 2, that q of x, the function is defined as either sin bx or cos bx, only sine or cosine. In such a case, the function particular integral can be find it as 1 by f of d into q of x, where here f of d can be written as fi of d square. It means that f of d is a algebraic polynomial in terms of a differential operator d. It may having constants, it may having a terms of d square, d cube, or like that. Wherever d square is there, the d square is replaced with minus a square. And this is applicable only when phi of minus a square is not equals to 0. If phi of minus a square is 0, that means when we substitute d square as minus a square, the denominator never becomes 0. Even if it's 0, then we are going to the case 2. That is minus x by 2a into cos ax. Okay. 1 by d square plus a square into sin ax is equals to minus x cos ax by 2a. Or 1 by d square plus a square cos ax, then x sin ax by 2a. Or simply we can also write like this: x by derivative of the denominator f dash of d into either sin ax or cos ax. Then now we replace wherever d square is there in the denominator, the d square is replaced with minus a square. Then x by f dash of minus a square into sin ax or cos ax. This is the other method. Here you need to remember that whenever we are finding the particular integral that completely solved, it means that without any operator in the final solution. Here d is an operator. What do you mean by d? That's a derivative, d by dx. 1 by d is also an operator, that is an integral of that particular function, whatever we are having with respect to x. Use these standard notations for finding the particular integral. If suppose when we substitute d square as a minus a square in f dash of d, sometimes it may having some derivative d terms in the denominator. Then to eliminate the d term, r d plus r minus a something, then you need to rationalize it. If you want more explanation, please go through the other videos which is in description box. Now, see here in the other method, q of x is x power m. Q of x is equals to x power m. Here observe this is only the polynomial. If it is the polynomial case, we are taking the least degree term as a common in the denominator and can be written in the form of 1 plus r minus something, that is in terms of ordinary derivative d. 1 plus r minus phi of d whole power minus n into x power m. For expanding this binomial formula, we are using these specific formulas. These are the binomial formulas. Use these binomial formulas. Expand 1 plus r minus phi of d whole power minus 1 or whole power minus 2 or whole power minus 3, and multiplying each term with x power m and then evaluate. Here evaluation means the d of x power m. What is the derivative of x power m? M into x power m minus 1, and so on like this. Applying the appropriate derivative to that particular term and then simplify. That is the third method. And coming to the fourth one, q of x is equals to e power ax into v of x. Till the third method, if you observe, each method is only the single function. There is no product of the functions. Here the fourth method is the product of two functions. In those, one must be exponential, e power ax into v of x. In such a case, just simply here e power ax into 1 by f of d plus a into v of x. Here this v of x may be sin ax or cos ax or x power n. That v of x is specifically sin, cos or x power n, then you will apply again either method 1, method 2 or method 3. Just apply that appropriate method here to find 1 by f of d plus a into v of x. Now coming to the fifth one, it is especially of the form x power m into v of x. x power m into, here it is of the form x power m into sin ax, or especially x power m into cos ax. Okay, now in such a case, here particularly here the power is degree is 1. Here observe, q of x is x power 1 into v of x, then particular integral, or we can represent it as yp or pi, can be find it as 1 by f of x into x v of x is x minus f dash of d by f of d into v of x by f of d here. Now it means that first apply this operator 1 by f of d on v of x first, and then apply the derivative here. In this order you need to evaluate it. X minus 1 by f of d into f dash of d into 1 by f of d into v of x. First apply this operator on this v of x function. It may be sine or cosine. Later you will apply the operator f dash of d. This is an operator d or d square or whatever it may be. Apply this operator on the entire the function, and then apply the operator 1 by f of d on the remaining function. Like that you need to, one after the other, you need to apply the operators. And the other way, what is the other? If it is power is other than 1, in such a case, find the particular integral for the case of cos ax. Here degree is other than 1. X power m cos ax can be written as, or here cos ax is replaced with real part of e power iax. 1 by f of d into x power m cos ax. Here cos ax is replaced with real part of 1 by f of d into x e power ax, e power iax into x power m. Like this you need to find it out. Otherwise, if it is a sine case, that sine is replaced with imaginary part of e power iax, like here, that you can use this. And after replacing this d by d plus a, because here which is converted into the fourth method, here if you observe, convert that into the fourth method, that if it is of the form e power ax, a in place of ax, iax here. So e power iax into 1 by f of d plus ia into x power m. Same as a fourth method, you will continue the remaining process. So this is the brief recall of the concepts of solutions of linear differential equation with constant coefficients. Now we are going to be linear differential equations with variable coefficients, that is particularly of the form Cauchy's homogeneous. Here we observe the coefficient of d cube y by dx cube is x cube, and degree of x is 3, and order of this derivative is also 3. At the same time, the remaining terms also the same. X power is 1, the order is 1. So, which is of the particularly of the form which is Cauchy's homogeneous linear differential equation, or we call it as a Euler's Cauchy's homogeneous linear differential equation. Now we need to convert this into constant coefficients just by using the substitutions. X is equals to e power t. It means that by logarithmic properties, t is equals to log x. Now already we discussed the what is the value of dy by dx. X dy by dx value is theta, or we can write in the short form x capital dy is replaced with theta y. X square d square y by dx square is replaced with theta into theta minus 1 into y, or simply write it as x square d square y is replaced with theta into theta minus 1 into y. Similarly, x cube d cube y is replaced with theta into theta minus 1 into theta minus 2 into y. Substitute all these values in the given differential equation. Now if we substitute all those, then we will get it as x cube d cube y is replaced with theta into theta minus 1 into theta minus 2 plus 3 times of x square d square is replaced with theta into theta minus 1 plus x into dy by dx is replaced with theta plus 8 whole, here I am taking y as a common, whole y is equals to 65 cos of log x is replaced with theta. So log x is replaced with the t. Now simplifying this, we will get it as theta into theta square minus 3 theta plus 2 plus 3 theta minus 3 theta square minus 3 theta plus 8 whole into y is equals to 65 cos t. So which is now again simplify theta cube minus 3 theta square plus 2 theta plus 3 theta square minus 3 theta, here minus 2 theta as we simplify, plus 8 whole into y is equals to 65 cos t. Now here we simplify, we will get it as minus 3 theta square and plus 3 theta square is cancelled, and here minus 2 theta and plus 2 theta is cancelled. You will get it as theta cube plus 8 whole into y is equals to 65 cos t. Now here if you observe all substitutions completed and simplifying, we will get it as theta cube plus 8 is equals to 65 cos t, which is linear differential equation with constant coefficients. With constant coefficients. Okay. Now, how to find the solutions of the constant coefficients? Complementary function plus particular integral. So, how to find the complementary function? The complementary function is depending on the roots of auxiliary equation. First, write the auxiliary equation. Auxiliary equation is f of m is equals to 0. Here it means that here observe this is of the form f of theta into y is equals to q of x. That's q of t. Okay. Now, f of m is equals to 0. It is obtained by just replacing this theta by m in the left hand side function. That is m cube plus 8 is equals to 0. Now, what are the roots of this equation? The roots are m is equals to minus 2, 1 plus r minus I root 3. Now here observe, here the given equation is a third order differential equation. So we will get the third degree auxiliary equation, that is a algebraic polynomial, third degree algebraic polynomial. Then you will get the three roots. How the roots are here? One is the real and distinct, two of them are imaginary and distinct. So first apply the concept for the distinct root. So complementary function is e power minus 2t. Here we are using t because here the independent variable is t. Plus, now we apply the complementary function for the distinct roots. What are the distinct imaginary roots? A plus r minus ib, which is of the form a plus r minus ib. For that one, we have the formula e power at. A means that is the real part, that's 1 into t into c1 cos bx, that is root 3. Here independent variable is t, plus c2 sine root 3t. This is the complementary function. Now how to find the particular integral? Particular integral is 1 by f of theta into q of x. That 1 by f of theta is nothing but we are getting theta square plus 8 into 65 cos t. Theta cube not square, that's the theta cube. Theta cube plus 8 into 65 cos t. So wherever that theta square is there, that's a method we need to apply the method 2. How could you solve that method 2? Method 2 is nothing but q of x. In place of q of x, we have either sine or cosine function. So particular integral is 1 by theta cube plus 8 into 65 cos t. Okay, in this case, the q of x is of the form cos t. So replace theta square as minus a square, that is minus 1. The t coefficient is here 1, that is a minus a square, that is minus 1. Now if we replace, then we will get it as minus theta plus 8 into 65 is a constant cos t. Now here if we observe, theta is here in the denominator. It means that an operator. The problem is not yet complete. So to complete the problem, to eliminate this operator, we need to rationalize it. 65 into 8 plus theta multiply and divide with 8 plus theta. Now simplify it. You will get it as 8 plus theta by 64 minus theta square into cos t. Again, if you observe in the denominator, we have theta square is there. That theta square is replaced with minus 1 again. 65 into 8 plus theta. What do you mean by theta here? D by dt. The derivative with respect to t. The d by dt of cos t by 64 plus 1. Minus of minus plus 1. Just simplifying, you will get it as 8 cos t plus derivative of cos t, d by dt of cos t. Now you will get it as 8 cos t, derivative of cos t is minus sin t. So 8 cos t minus sin t. This is our particular integral. Now what is the complete solution? The complete solution or general solution is y is equals to complementary function plus particular integral. What is that? What is our complementary function? Here this is our complementary function. C1 e power minus 2t e power minus 2t plus e power t into C1 cos root 3t plus C2 sin root 3t plus particular integral, that is 8 cos t minus sin t. Here why we are in terms of the complete solution is y in terms of t, but actually our problem is the dependent variable is y and independent variable is x. Always the solution of differential equation is relation between dependent and independent variable. So we need to write the total solution in terms of x just by replacing where t is equals to log x. Just replace that value, c1 into e power minus 2 log x plus e power t means that log x, directly you can write, sorry, e power log x, that value is x, x is e power t. Then c1 cos root 3 log x plus c2 sin root 3 log x plus 8 into cos of log x minus sin of log x. Then you can more simplify this one. E power minus 2 log x can be written as x power minus e power log x power minus 2. Then you can simply write in place of this 1 by x square. This is e power minus, you can apply the logarithmic properties, log x power minus 2. This value is same as e power log to the base e is base e of x square value is the same as the function value x power minus 2, which is 1 by x square. Then you can replace entire e power minus 2 log x as 1 by x square also. You can simplify like this. Some more problems on this. Now, first here we observe this. Is this in the Cauchy's homogeneous or not? Here the degree of the term is same as order of the different derivative is same as the degree of this term, and x square d square y by dx square plus 2 times of x dy by dx. So plus y is equals to x plus log x whole square. So it is of the form Cauchy's homogeneous, which is of the form Cauchy's homogeneous linear differential equation. In such a case, we need to convert these variable coefficients into constant coefficients by using some little substitutions. What is that? X is equals to e power t, then t is called it as a log x, and dy by dx already we discussed in the last video. Then we can replace that x dy by dx as theta into y, and x square d square y by dx square is replaced with theta into theta minus 1 into y, where theta is d by dt, where theta is d by dt. Now substitute all these values in the given differential equation, that is theta into theta minus 1 plus 2 into theta plus 1, here I am taking y as a common, is equals to, replace x as a e power t, and log x is replaced with t, that's a t square. Now simplifying, you will get it as theta square plus theta plus 1 whole into y is equals to e power t plus t square. Here if you observe, this is a linear differential equation with constant coefficients. Now, what is the solution of this LDE? Y is equals to complementary function plus particular integral. How to find the complementary function? That complementary function is depending on the roots of auxiliary equation. So, first find auxiliary equation. Auxiliary equation is theta square plus theta plus 1 is equals to 0. Or you can replace that theta as with m square plus m plus 1 is equals to 0. M value is using the formula, discriminant formula, that minus b plus r minus square root of b square minus 4ac by 2a. Using this formula you can find it out, minus b plus r minus square root of b square minus 4ac, that's minus 4 by 2a. Now which is minus b means that minus 1 plus r minus I root 3 by 2, which is nothing but minus 1 by 2 plus I into root 3 by 2. Now what is the complementary function for this? Complementary function is, here observe the nature of the root, that is imaginary and distinct. This is a second order differential equation. We are getting here two roots and both are the real and imaginary. So c1 e power minus t by 2 into c1 cos root 3 by 2t plus c2 into sine root 3 by 2 into t. Now find the particular integral now. Particular integral is 1 by f of d into q of x, that is the right hand side function, that is e power t plus t square, not f of t, that is f of theta here. Now 1 by f of theta, theta means that theta square plus theta plus 1 into e power t plus t square. Then you can split it now, 1 by theta square plus theta plus 1 into e power t plus 1 by theta square plus theta plus 1 into t square. Here observe, These are the two terms. Then you can take it as a pi1 plus pi2. Then solve one after the other. pi1 is 1 by theta square plus theta plus 1 into e power t. Here the right hand side function is exponential, so you can replace theta as a. A means that here coefficient of t in the exponential, that is theta is equals to 1. If we replace theta is equals to 1, then the denominator is never becomes 0. Before writing, before solving, you can identify or check whether the denominator is 0 or not. Here when we replace theta is 1, you will get it as 1 plus 1 plus 1, that is 1 by 3 times of e power t. This is the value of our pi1. Now we need to go for pi2. pi2 is 1 by theta square plus theta plus 1 into t square. Here observe how what is the right hand side function? That's a polynomial. Apply the method 3 for finding the pi2. So for the polynomial case, we need to use the binomial expansions. So here take the least degree term as a common, and here 1 is there. So you can write it as 1 plus the remaining function is considered as phi of d, all the terms, that's a theta square plus theta whole power minus 1 into t square. This is theta square plus theta. Now we will expand using the formula 1 plus x whole inverse. The binomial formula for this one is 1 minus x plus x square minus x cube and so on. Now using this formula we will expand that pi2 is 1 minus theta square plus theta plus theta square plus theta whole square and so on into t square. Now pi2 is, once again we will write this equation, 1 minus theta square plus theta plus expand this term, expand theta square plus theta whole square, that is theta power 4 plus, here observe theta square plus theta whole square, theta power 4 plus 2 theta cube, 2 theta cube plus theta square and so on into t square. Here what is the derivative, nth derivative of nth degree polynomial is n factorial. What is n plus 1th derivative of nth degree polynomial is 0. So based on this, here we will consider only up to the second derivative, because it is the second degree polynomial here, t square. So we are considering here up to theta square. Theta is nothing but the derivative with respect to t. In the next term, we are getting here theta square plus theta whole cube. All the terms are higher than the third order. So third derivative of t cube itself is 0 and all the other higher orders. So we consider only up to the second derivative. Now multiply each and every term with t square. Then t square minus theta square of t square minus theta of t plus theta power 4 of theta t square plus 2 times of theta cube of t square plus theta square of t square. Okay, now we will simplify, we will get it as t square minus theta square, that means a second derivative, d square y by dt square. Theta square is nothing but d square by dt square d square by dt square of t square. That value is second derivative of t square with respect to t is the 2 factorial. 2 factorial minus theta of t square, that d by dt of t square, that is 2t. Then you can write that value here, 2t plus fourth derivative of t square is 0. Third derivative of t square is again 0. Second derivative of t square is 2 factorial. Just simplify, you will get it as t square minus 2t. These two terms gets cancelled, you will get it as this. So now here pi1 is over. Here pi1 we got the value of this and pi2. Now we will write the complete solution. So what is the complete solution? Complete solution is complementary function plus particular integral. So y is equals to complementary function. Here the complementary function is this. Write this value c1 into e power minus t by 2. Sorry. Y is equals to e power minus t by 2 into c1 cos root 3 by 2 into t plus c2 into sine root 3 by 2 into t plus pi1. What is that pi1 now here? pi1 is 1 by 3 e power t plus 1 by 3 e power t plus pi2. What is the pi2 value? T square minus 2t. Now we replace the t as a log x, where t is equals to log x or x is equals to e power t. Using this substitution, convert the total equation is convert in terms of x. Here e power minus t, here e power minus, here simply write it as e power minus t is a log x by 2. Okay, so now we can write it as e power log x power minus 1 by 2 to the base e. So now which is nothing but minus x power minus 1 by 2, or it is 1 by root x. So now you replace this value with root x, 1 by root x. 1 by root x into c1 cos root 3 by 2 into log x plus c2 sine root 3 by 2 into log x plus 1 by 3 into e power t is replaced directly with x plus t square, t is replaced with log x whole square minus 2 log x. Now this is the complete solution or general solution. Here we observe the order of differential equation is 2, and here we have here 2 arbitrary constants are there. So we call it as a general solution. In a general solution, the number of arbitrary constants are same as the order of differential equation. So we call this one as a general solution. Thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.